Solving application problems using quadratics. Please keep this in mind. When solving application problems that lead to quadratic equations, there might be a solution that does not satisfy the physical constraints of the problem. For example, if x represents a width of a garden and the model equation is quadratic with two distinct solutions, one of the solutions might not make sense. For instance, if one solution is positive and the second negative, the negative solution must be discarded because the width of the garden must be positive in value. In a case like this, the discarded value is called an extraneous solution. Example A. Two cars leave an intersection at the same time, one heading north and one heading west. Sometime later, the cars are exactly 150 miles apart. If the car headed north has gone 30 miles farther than the car headed west, how far have each of the cars traveled? Here is a diagram of what we've described in the problem. So two cars are headed away from each other. One of them has gone a distance x, the other has gone the distance x plus 30. So we know that this distance is 150 miles. So now, once we let x equal the distance traveled by the westbound car, and x plus 30 is the distance traveled by the northbound car, we can use the Pythagorean theorem to solve. X squared plus x plus 30 squared equals 150 squared. When we solve this, we get it into the quadratic equation just like this, and we can then solve this by factoring, and we see that there are two solutions, where x equals negative 120 or x equals 90. But since the distance cannot be negative, we can discard the negative solution. The distances are 90 miles, and so x equals 90. Therefore, this distance here is 90 plus 30, which is 120. Example B. A rectangular lawn area has a length of x plus 12 feet and a width of 2x feet. A square patio is built into one corner with dimensions x by x, reducing the area of the lawn. The new lawn area is 356 square feet. To the nearest tenth of a foot, what are the dimensions of the patio? Alright, so what we need to do is figure out the area of the full rectangle and then subtract the area of the patio. So the area of the rectangle will be 2x times x plus 12. Then we just subtract x squared because the area of the patio is x times x, and we set that equal to 356. We know that the area of the green shaded area is 356, so now we can solve for x to figure out the dimensions of the patio. So we have our quadratic equation here. We're going to complete the square because we add 144 to both sides. Therefore, we have x plus 12 squared equals 500. We can solve, take the square root of both sides. We get negative 12 plus or minus the square root of 500, but in this case, we're only going to use the plus, not the minus, because the minus answer is going to be negative, and only positive answer can be applied here. So the answer is going to be about 10.4 feet. The patio is 10.4 feet by 10.4 feet.